Swayam Prabha. Digital India. Educated India.
Okay. So, we have discussed about that critical distance, we calculate the critical distance and the importance of the critical distance. Now, there we have mentioned the percentage alcon. What is percentage alcon? Alcon is articulation loss of consonant. Percentage alcon means percentage of articulation loss of consonant. That is why it is called percentage alcon. The formula percentage alcon is 200 into r square. R square is the distance, Tr is the reverberation time, N is the number of reinforcing loudspeaker plus 1 divided by Q is the directivity factor and V is the volume. So, if all the parameters are given, I can calculate the percentage alcon. Now, what will happen for percentage alcon? What is percentage alcon? What does the percentage alcon number mean? The low number means if the percentage is very low, percentage articulation loss of consonant. So, if the percentage is very low, then the percentage of loss of consonant is low. So, it is good for if the percentage alcon value is low, means less number of consonant are lost. So, intelligibility of the speech, if it is measured based on the percentage alcon, then the percentage alcon should be low to make the speech more intelligible, because loss of articulation is less. So, there is a value is called 10% is good and 15 is the limit beyond which intelligibility is decreased. If it is more than 15%, the speech intelligibility of that auditorium is very less. Why I said that percentage loss of consonant is also acceptable? Now, if in human speech, if you see there is a lot of consonant and vowel combination are there, all consonant are not that important to understand that what the speaker is saying. Even if you see when we exposed to a some such talking or speech lectures, even if some of the word or some of the syllable, some of the consonant is dropped, then also you can understand that speech. So, that is why there is some redundancy of the consonant clarity exists in the speech. Although there is some consonant is not clear, then also you can understand the speech. That is why percentage alcon of 10% means 10% articulation loss of consonant is acceptable for an auditorium design. Okay. Now, how do you calculate percentage alcon? The formula is given. So, if the parameters are given, room parameter means R is the distance from the speaker to the listener. So, I know that for this seat what is the percentage alcon if I want to calculate, then I know the reverberation time of the auditorium, volume of the auditorium, directivity factor of the auditorium of the depending on the placement of the loudspeaker and number of reinforcing loudspeaker on that auditorium. Now, for an example, let us do a mathematics that suppose given a room dimension is given 12, 14 and 6 meters, is a square kind of room and there A is given, average observability is given. Calculate capital A in 7 and Tr means reverberation time. Can we calculate Tr? How do you Tr? Tr is nothing but a 0.161 V by A. What is A? A is nothing but a S into A. What is S? S is nothing but a surface area of a square room. So, 2 into length into length into height plus length into width plus height into width. So, I know the dimension and I can calculate S, then I can calculate the length into height into width, I can calculate the volume. Once I know V and S, once I know S, I can calculate A, then I calculate V, then I can calculate reverberation time. What are the lowest 5 standing wave frequency? What I said F N1, N2, N3 is nothing but a, what is the formula? C by 2L, C by 2 root over of, what is the formula? Formula I told you the formula in the last lecture. I give you that formula. Formula is nothing but a, if I see this formula is nothing but a C by 2 root over of n1 square by L square plus n2 square by this W square plus n3 square by H square. So, length, width and height. So, if I say lowest standing wave frequency, if I say it is the lowest standing wave frequency, lowest 5 standing wave frequency I said. So, what is the lowest frequency? When it will be the F? F will be lowest. When F, if any all are 0. So, if that let us that what is the width? Width is maximum, width is 14. So, if this width is large, then this parameter will be low. So, I can say F010 will be the lowest frequency, that is C by 2 root over of 1 by 14 square. Okay. Then next highest, when the height will be there, F00, F100, that is nothing but a C by 2 is root over of 1 by 12 square. Then F001 is root over of that things. So, now that way you can calculate the lowest 5 standing wave frequency. Similarly, how to calculate if a, now I said if a 3 into 10 to the power minus 6 watt average output acoustic source is placed in the front center of the front wall, find reverberation level in dB. So, center of the front wall, this is the room, I place a loudspeaker center of the front wall, okay, whose wattage is 3 into 10 to the power minus 6 watt. Okay. Now, if it is placed, then what is the directivity of the loudspeaker? It is placed on the single wall. So, Q is nothing but a 2. Okay. Once I know Q, then what is LR? Reverberation sound level is nothing but a source plus 10 log A by 4 by A. You know that formula. What is the formula? Reverberation sound level at any point on that room is nothing but a, if you see, I just can open that lecture number 1, I see the formula, I show you the formula, not lecture number 1, it is in lecture number 2. So, it is nothing but a that formula. LR, reverberation sound level, is nothing but the LW is the sound source level plus 10 log 4 by A, okay, 10 log 4 by A. So, what I said, to find out the reverberation level in dB, power level in dB. So, it is power, reverberation sound power. So, power is nothing but a source. What is LW? LW is nothing but a 10 log power 3 into 10 to the power minus 6 divided by 10 to the power minus 12 is the reference power 0 dB. So, that dB, I got this LW. Once I know the LW, then plus 10 log 4 by A, I know the A from the previous slides, the A is nothing but a S into A. So, I got the A by 4 by A and I get that dB. Okay. Then I said the total dB at distance 3 meter from the source. So, if a 3 meter from the source, then total power LT is nothing but a direct sound power plus reverberation power. So, what is LW plus 10 log Q by 4 pi R square, R is the distance, plus 4 by A, that is the formula. So, I know the Q is equal to 2, R is equal to 3, I know that things, and I know A. So, I can find out LT also in the critical distance. What is critical distance? When I said critical distance are that distance where the direct sound power and reverberation sound power is same. So, Q by 4 pi DC square is nothing but a 4 by A. So, DC square is nothing but a Q into A by 16 pi. and dc is nothing but a root over of q into a 16 pi. Now, once I know that, then what is dc? For this room I know a, I know q equal to 2, I know a, and then I can calculate that dc in meter. Okay. Then I said percentage alcon, calculate the percentage alcon. What is the percentage alcon formula? Formula is percentage alcon, ALCONS is nothing but a 200 into r square. R is the distance, TR is the reverberation time, N is the number of reinforcement speaker, and Q into volume. Okay. So, what is in the formula? In the problem, what is given? R is equal to 3, for 3 let us R is equal to 3, and Q is equal to 2, TR I have to calculate. How do you calculate? I know that TR I calculated from here 16,161 V by A. So, I calculate TR. So, TR I know, and N I said is only single source is placed. So, single source is placed means N plus N is 1. So, 1 plus 1. So, I know this factor, I know this, I know this, I know Q, I know volume. So, I can calculate the percentage alcon. And if I say comments on your percentage alcon, so if it is above 15%, I can say this is not a good room for speech intelligibility. Okay. I can calculate the percentage alcon. So, when you design an auditorium, if somebody said, can you calculate that distance from the stage, distance from the source, let us 2 speaker I place in the 2 side of the wall of the front of the auditorium, the stage side of the auditorium, then from speaker to any distance I can calculate the percentage alcon. Okay. Speech intelligibility. Then there is another term is called initial signal delay gap. So, I said that if in any enclosure room, if I play a source, sound source, then at any point from the source it will be a direct sound and there will be a number of reflection sound. So, I can say if suppose this is an enclosure room and if there is a source in here, and if in this point there will be a direct sound and there will be a reflection sound from different path of the reflection. So, initial signal delay gap is the time between the arrival of the direct sound. So, time let us TD is the direct sound time arrival, and first reflection, let us first reflection came in T1. So, the time delay T1 minus TD is the initial signal delay gap. Okay. So, this is called ISD, initial signal delay gap. So, at any point I can say the distance, the time taken by the direct sound, difference between the time of reaching of direct sound and first reflection is called initial signal delay gap. This is the fundamental room parameter, this is used, ISD is used. So, for a small room, for a recording studio, it should be 1 to 5 millisecond. The initial time, initial delay should be 1 to 5 millisecond. Okay. Now, there is another parameter, live end and dead end. For a small room, this parameter is very much useful. Live end and dead end. For design of control room for monitoring recording studio, this is used. So, front half of the room was made absorptive as possible and other half was made reflective and diffusive. So, in a small room, front half is absorptive and other half is reflective. So, the total power LT is contributing by the sound source, reflection power and ambience noise. So, LR is the reverberation sound, direct sound and noise is contributing to the total sound level. So, direct sound, reflective sound and ambience noise, if there is a ambience noise, that noise also contributing the sound power. Okay. Next, factor to which for a room, factors to watch for a room, that means factor to watch for a room. What is the meaning? When you design an acoustic studio, which are the factor you should look. First is curved surface, especially concave curved surface. There should not be any concave curved surface. Okay. Then absolutely parallel wall, such wall, that wall cause flood or echo. When you design an auditorium, there should not be two absolutely parallel wall. Okay. Then absorption on the ceiling. If you put absorptive material on the ceiling, then you lose sound energy. Unless the ceiling is very high, now the placement of the absorption on it means that sound system lost some useful reflection. If it is above 60 feet, what will happen? That it creates an echo. That in that case, to reduce the echo, we put absorptive material. But if the ceiling height is not above 60 feet, then we should not put absorptive material on ceiling, because it unnecessarily lose that acoustic energy. Potential ambient noise source, there should not be a potential ambient noise source in just close to the auditorium, then the ambience noise level will be increased. Extra wide or round audience seating, this is very important. What I said, that in critical distance, that after the critical distance, the direct sound intensity is less than the reverberant sound, then it creates an effect that the clarity of the speech will be, clarity of the sound will be hampered. So, we want that audience should be as close as the some factors of direct critical distance. So, if I make a hall like this, and that critical distance is this, so it may be a 10 times the critical distance, which means if some person sitting in here, the direct sound and the reverberation sound, direct sound has no intensity. So, he feel only the reverberation sound. So, intelligibility of loss. So, what I said, that if you make a extra wide range sitting audience, extra wide 120 degree, you know that extra wide sitting arrangement, then this can be avoided. Okay. Next, early reflection. The time of first reflection is an important aesthetic parameter in auditorium acoustics. If the first reflection is delayed by greater than the 35 millisecond, then what will happen? Echo will come, which is not desirable for a auditorium. So, first reflection must be within the 35 millisecond. The best value obtained by evaluating good concert hall or less than 35 millisecond, which is 20 millisecond for intimate hall. Okay, I will come what is intimate means or all those things. So, 20 millisecond is good, but not above 35 millisecond. In that case, echo will hard. Even in presence of reflection, we can localize the sound source if the similar sound arrive at ear within 35 millisecond the direction of the source. Forget about the reading. So, what I said, the human being perceive the direction of the sound based on the first arrival of the sound. Which is first arrival is the direct sound. So, always we perceive sound is the direction of the direct sound. So, if the reflected sound is come within 35 millisecond, it does not create another sensation of the same sound. So, we are not hard echo. So, the direction of the sound will be the direction of the direct sound. If it is greater than 35 millisecond, then we can heard a sound is come from a direction of the source and a sound is come from the reflection of the source. The same sound is reflected back reflected. So, echo, as if you create an echo, what is that direction of the echo? Direction of the echo is the reverse of the source. If you see, if I create a sound in here, it is reflected back and produce an echo, after 35 millisecond it reach my ear. I heard first sound, which is direct sound, and next sound is the reflected sound, which is come as if I assume that it is come from my front side. Okay. So, the sound which is I perceive direct, that is the direct sound direction of the direct sound. If the reflected sound are within the 35 millisecond. Okay. Then there is some acoustics parameter for any acoustics room. There is some parameters, measurement parameter. One is called liveness, intimacy, flueness and clarity, fullness or clarity, warmth or brilliance, texture, blend, ensemble. So, all are the 7 acoustic parameter which we have to know, which are define the quality of the acoustic treatment of the room. So, what is liveness? Liveness is a measure of reverberation time. So, liveness refers directly to reverberation time. A live room has a long reverberation time and a dead room has a small reverberation time. So, in anechoic chamber, the liveness is dead, 0, means reverberation time is 0, because there is no reflection. So, there is no reverberation time. So, live room are those rooms where the reverberation time is much larger. Okay. So, that is called liveness. Then intimacy refers to how close the performing group sound to the listeners. But what is the human tendency? Suppose a orchestra is performing on the stage, you know that we have to buy a high value ticket to sit in the front of that orchestra. That means, if the audience is feel it is close to the orchestra, so intimacy is that refer to how close the performing groups sound to the listeners. If a listener sitting on a far seat, how he feel that he is close to the orchestra. So, room said to be intimate when the first reverberation arrive within 20 milliseconds of the direct sound. So, if the first reflection to the listeners arrive within 20 milliseconds, so I make arrangement of all the reflectors such that the direct sound and reflection sound, difference between the two sounds in time is 20 milliseconds, then a person will feel that I am intimate with that orchestra which is performing in the stage. So, this condition is met easily in a small room. So, if it is a small room, the reflection path is less, so it can be easily met, but it can also be achieved in a large hall by use the orchestra cell that particularly enclose the performer. So, we enclose the performer means we use you increase the directivity. So, the reflected sound will come, reflected sound intensity will be very high. Okay. Then you know that in church also that is done. So, this is the way how can you increase the intimacy. Then fullness and clarity. Fullness, what is fullness? The amplitude of the reverberant sound relative to the direct sound is referred to the fullness. So, I said the amplitude of the reverberation sound relative to the direct sound. So, if the reverberant sound by direct sound is actually define the fullness. So, more the reflected sound, more the fullness. So, fullness is nothing but a reflected sound divided by direct sound intensity, reflected sound intensity by direct sound intensity. Okay. Amplitude means it can contribute to the intensity. So, if that is the case, then the fullness will be more if the reverberation sound intensity is high. Okay. So, reverberant sound is predominating in the direct over the direct sound, means close relation. So, if it is equal, then the fullness is 1. Okay. But what is clarity? Ability to distinguish and articulate individual sound, the opposite of the fullness. So, if it is, suppose in a stage there is a 3 performer, somebody is playing guitar, somebody is playing sitar, somebody is performing vocalist. So, clarity is the ability to distinguish the articulator individually. So, how am I able to individually identify those sound is defined by the clarity, which is opposite to the fullness. If the reverberation sound is a ensemble sound, direct sound is coming from the sitar, then there will be a maybe a guitar and there will be a vocalist. So, I close my eyes, I understand that yes, individually I can identify the sitar is sitting in this side, guitar is sitting in this side and vocal is sitting in this side. So, I identify that fine, that direct sound give me. But if the reverberant sound is also very intense, then what will happen? The fullness is very high, but the clarity will be confused. because all reflection will come together to me. So, clarity will be confused. So, clarity is the opposite of fullness of the sound. Okay. So, clarity C80 is defined by energy arriving within 80 millisecond of the direct sound and energy within later 80 millisecond after the direct sound. So, what is reflected sound? Within 80 millisecond of the direct sound, some energy will come, and energy that is defined by the clarity. So, while more clarity would be, so a fuller sound is generally required a romantic music or performance as a larger group. So, I require a ensemble, or you can say that full sound, that I do not want to clarify who is performing, because there is a huge large group is performing. So, individual artist I do not want to identify. So, what I want a full sound, sound intensity should be very high. So, in that case I go to the fuller sound, but the clarity sound, for suppose somebody giving a lecture, then I want to listen that lecture and somebody is playing or somebody, some vocalist, and there is a setar, there is a guitar, I want interested on the vocalist. So, I have to critically identify the vocalist. So, clarity is very important to me. Okay. So, in that case, that is why the fullness and clarity is defined. Then this parameter refer to the reverberation time at low frequency related to the at higher frequency. That means, about 500 Hz the reverberation time should be the small for all frequency, but at low frequency an increase in the reverberation time create a warm sound, while if the reverberation time increase is less at low frequency, it create a brilliant sound. Okay. So, this is the definition of warmth and brilliant. Then texture. Texture refer to the time interval between the arrival of the direct sound and the arrival of the first few reverberation sound. This is 5 reverberation. So, this texture is defined by the direct sound interval between the arrival of the direct sound and first few reflection sound. So, to obtain a good texture, it is necessary that the first 5 reflection arrive at the observer within about 60 millisecond of the direct sound. That is the good texture. Within the 60 millisecond, some reflection must, at least 5 or 6 reflection must come, then it is a good texture room. So, important corollary to this requirement is that the intensity of the reverberation sound should decrease monotonously. So, there is a assumption that if the intensity, so actually what is the meaning? Meaning is that suppose this is the source. So, I said the texture will be good if the direct sound, the time interval between the reaching of the direct sound and few 5, let us 5 or 6 few reflection, 5 reflection, first 5 reflection as minimum as possible. If it is decreased, the texture will be good. So, it should be within 60 millisecond at least, then the texture will be said at least good texture. So, as low as possible. So, difference time. So, I said the first I have measured the direct sound arrival at this point and then measured the first reflection arrival time, second reflection arrival time. When the fifth reflection arrival time is came, let us say it is T1 and direct sound is Td. So, T1 minus Td is the texture, it defines the texture. Okay. So, if it is within 60 millisecond, then we said texture is good. But suppose there is such a reflector that fifth reflection or fourth reflection come intense compared to the first reflection, then I feel little bit of uncomfortable. Sometimes sound is bouncing and then going down, bouncing and going down. So, I do not want that things. So, generally what happened, since the first reflection path and second reflection path is, first reflection path is less than the second reflection path, as per the inverse square law, the 3 dB down will be there, decayed. So, I can say the first reflection intensity, if it is IR1, if it is IR2, IR1 must be greater than IR2 because of path is different. Okay. Large number of path is taken in the second reflection, it is the time. Okay. Now, if say let second reflection is very high, then it create uncomfortable. So, then texture is not good. So, in that texture will be good if these 5 reflection come within 16 millisecond and the intensity of the each reflection gradually decrease or linearly decrease, then we said the structure of the room is good. Okay. Then blend and ensemble. Blend refer to the mixing of the sound from all the performer and their uniform distribution to the listeners. What is blend? Blend means blending, sound blending. So, mixing of the sound, suppose in a stage there is a lot of musician. So, blending means the mixing of the all sound and uniformly distributed to the listeners. So, if a listener sitting in front of the stage and a listener sitting in the just far away from the stage, both listeners should not say the first listener is heard that okay, guitar is playing loud, and second last listener is heard now tabla is playing loud. That kind of thing should not be there. So, blending of the sound must be proper to all listeners. Okay. Then ensemble refer to the ability of the member of the performing group to hear each other during the performance. If you say in a stage, any audio stage, any when a musician perform, if you see there is a reflector on the stage, that is called monitor, reflector. So, that since when a performance group sitting in a stage, they cannot hear the reverberation sound, because the reverberation will come from the back end of the stage and the reverberation sound will be not audible to, maybe intensity is very less. So, what they want a extra sound reinforcement to hear that other performer sound. That is why there is a reflector is placed on the stage or monitor is placed on the stage to performing group to hear each other during the performance. That is called ensemble. Okay. Then what are the problem in acoustic design? There is a few problem in acoustic design. We have to avoid focusing of sound. When I design an auditorium, there should not be any particular place where the sound is focused. We have to avoid echoes. There should not be any echoes. We have to avoid shadow. What is sound shadow? We discussed diffuser. If diffraction, if there is an obstacle of the sound, it create a sound diffraction. So, due to the diffraction a shadow will be created. So, I do not want a shadow region in the auditorium. Then I do not want the resonance. There will be a resonance is happen in the auditorium, because I want a reverberant sound fill in auditorium. Then I want external noise. I should not want the external noise source should enter in the auditorium. So, those are the factors I have to taken care during the design, acoustic design of the auditorium. One is called focusing of sound. There should not be, suppose I want to design an auditorium, I want to design an acoustics room or auditorium like this, and I put a regular reflector here. So, if a sound is come in this direction and it will be go in this direction, so this portion sheet will be focused. So, I do not want the focusing of the sound. So, I do not want there will be a regular reflection in the surface. So, if I want to avoid the regular reflection, what I required? I required a diffuser surface. What is diffuser? So, what is regular reflection? Regular reflection is that if the surface is very smooth, so there will be a regular reflection, angle of reflection and angle of that this ray will, suppose the sound is coming from this direction and it is going in a single direction. So, I want a irregular or diffuse reflection, that means irregular random reflection. So, in that case all direction the reflection will be happen. So, each point of the auditorium the reverberation field will be same. So, I have to treat the wall of the auditorium or what the reflector of the auditorium is by a diffuse reflector. Okay. So, what are the diffuse reflector? There is some material is available on the, so diffuse reflector can be like that, random scattering from a rough and textured surface. So, if the surface is very rough, then there will be random reflection will be happen, but easy to make. I can make a rough surface of the auditorium. I can, instead of polishing the wall of the auditorium, I can make a rough surface, but not predictable in response, because I don't know, I cannot predict the response. So, I require a control diffuser. So, what are the control diffuser? If you see, this kind of diffuser is there, acoustic tiles which is treated in the wall. So, quadratic residue method, one of the design method for diffuser is quadratic residue method. I am not going very details, but at least you should know what are the diffuser is available. A method of designing multi-level diffuser that operate over a greater wavelength range. Okay. So, frequency response and design of the diffuser, there is a relationship. So, if you see, there is a acoustic style, there is a quadratic so there is a, if you see, this is the tiles, there is a depth. So, this depth is not random, this depth is designed. If it is quadratic residue diffuser, depth is nothing but a lambda 0 is the fundamental wavelength divided by 2p into Sn. P is an integer. Okay. Sn is a sequence which can be defined, which can be generated using this. N is an integer. N varies from 0, 1, 2, 3, 4, 5, 6. Let us p is equal to 16. Then I can get an Sn sequence. Then I can get a depth sequence. Okay. Then there will be a wall width and diffuser bandwidth. So, if you see, there is a slot like this way, wall, then we have a slot diffuser, we put a slot. If you see the auditorium, the front part just enclosure to the stage, just close to the stage, there is a slot, wooden slot is placed on the wall. So, this slot width and depth is not random, it has to be designed based on that requirement. So, you know the frequency of operation of the auditorium, then we have to design the depth on based on that equation. So, maximum wall depth should be 1.5 times the wavelength of the lowest frequency, because if it is support for the lowest frequency, it will support for the highest frequency. So, the maximum wall depth should be 1.5 times the lowest frequency of operation of the auditorium. So, if it is a music studio, a music auditorium, then it is 30 hertz. If it is only for speech auditorium, then it is 80 hertz is the lowest frequency. So, I know the lowest frequency, then I know I know the wavelength, and then 1.5 times of the wavelength will be the depth. Okay. Then wall width should be 0.5 the length of the highest frequency of the operation. So, width will be the 0.5 times the highest frequency of operation. So, if I say music 20 kilohertz, then I know the lambda, then I find out the width. Then the highest frequency to the lowest frequency define the operating bandwidth of the diffuser. So, if a diffuser work for let us 30 hertz to 10 kilohertz, then I can calculate the depth and width of the slot, then according to I can treat that things. So, there is a number of other diffuser also, there is a slot absorber is there is use of slot absorber, reduce the slot absorber. So, there is a diffuser. Okay. Now, there is a absorber also. What I said, I have to make the auditorium such that there will be no focusing of sound, that is the job of the diffuser. So, all the reflective surface must be treated as a diffusive reflection, no polished surface. If it is a polished surface, regular reflection, which has to be avoided. Then I have to avoid the echo. So, if my far end, let us the auditorium is huge, large auditorium, if the far end is very lengthy, then maybe the reflection come in 65 more than 65 milliseconds. So, I do not want to the reflection more than 65 milliseconds reflection should come. So, all the far end must be treated as a absorptive material which can absorb the most intensity of the sound. So, there will be reflection intensity will be greatly reduced, so that there will be no echo. So, the far end of the auditorium must be absorptive, and the sometime some absorptive material is required in the middle also, because that also created echo for some point. So, absorption, there is some absorptive material also required. So, what kind of material is there? For absorption, I require a slot absorber. I can use a slot absorber. You can read that slide for that use of the slot absorber, or I can use the perforated panel absorber, where the frequency is the formula is given. So, perforated panel absorber like this. This is an absorber, acoustics absorber. So, absorption coefficient is given for different frequency. So, when you buy a absorber from the market or acoustic tiles from the market, the absorption coefficient with the frequency will be written on that packet. So, you can use that material. Once you treated the wall using that material, you know the total absorption A in 7, then that will affect the reverberation time. So, when we design the auditorium, we should taught or we should explain which portion of the auditorium should be absorptive, which portion of the auditorium should be reflective, and which portion of the auditorium should be more absorptive. So, those kind of treatment will make when you design that auditorium. But for design any studio or auditorium acoustic room, or even if you are drawing room acoustics, that it should be, there is no focusing of sound, there is no echo, there is no shadow, there is no resonance, and external noise source must be minimized. So, if you see that I build an auditorium near the highway line and I do not take care about that highway noise to pass the auditorium, then auditorium is useless, because the highway noise will easily enter that auditorium. So, how to avoid that external noise, keep the external noise source more away from the auditorium, that is the basic consideration for auditorium design. Okay. Now, there is another things, room treatment. So, I said that room treatment means how do you design the auditorium, it depends on what is the purpose of that design the auditorium. If it is a auditorium is designed for a classical music or performance of the classical music or orchestra, then the design treatment will be different. If it is only for a lecture theatre like classroom, then the reverberation time requirement will be different, and the treatment of the acoustic treatment will be different. So, next class we will discuss about how to design an auditorium acoustics, or which part of an auditorium should be treated in which kind of material and why. And the most common phenomena is that there should not be any parallel wall when you design an acoustics auditorium or even in room acoustics. If it is parallel, it creates a, so there will be at least some sliding of the wall, which is good for the design a very good acoustics room. Okay? Thank you.